The substances which are attracted by magnetic field, they are called as paramagnetic substances. The substances which are repelled by magnetic field, they are called as diamagnetic substances. Mu is equal to square root of n into n plus 2. Square root of n into n plus 2 is the formula which is used to find out magnetic moment. Most of the metals which are belongs to 3D series, they behave as catalyst. Good morning, my students. I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Today, in this session, I am going to discuss about the third session of chapter D and F block elements. Already I discussed about first and second session of D and F block element. Today, it is a third session. As you know, in the first and second session, I discussed about what are the general properties of D block elements, what are D block elements, as well as 3D series, 4D series, 5D series, as well as 6D series, how they are arranged and their electronic configuration, atomic radii, ionic radii, ionization potential. I discussed everything. Okay. In the previous session, I discussed about ionic radii, trends in properties of transition metals of first series, or it is also called as 3D series. Last one, I discussed about oxidation state. As you know, the first member and last member of each series, they have only one oxidation state. All other elements, they have variable oxidation state. I already discussed about why the D block elements exhibits variable oxidation state because of the involvement of both Ns electron as well as N-1d electron. They have variable oxidation state. The first member and last member, they have only one oxidation state. Today in this session, I am going to discuss about 5 properties of this D block elements as well as 3D series. First one, magnetic properties. Second one, they form colored compound. Third one, catalytic properties. Fourth one, formation of interstitial compound. Last one, alloy formation. What are the 5 important properties today? In this session, I am going to discuss the first one, magnetic properties. First one, magnetic property. Second one, formation of colored compound. Most of the D block elements in their ionic form as well as in their salt form or in their compound form, they are colored in nature. What's the reason? Most of the D block elements as its ions, they are colored. And catalytic property, they behave as catalyst, and formation of interstitial compound as well as alloy formation. First one, let us consider magnetic properties. Let us consider magnetic property. As you know, some of the substances or elements, they are attracted by magnetic field, some are repelled by magnetic field. Based on that, there are 5 types of magnetic substances: paramagnetic, diamagnetic, ferromagnetic, ferrimagnetic, antiferromagnetic substances. But in this chapter, I am going to deal with 2 types of magnetic substances. One is paramagnetic, second one diamagnetic. Paramagnetic substances as well as what? Diamagnetic substances. What are paramagnetic substances? Paramagnetic substances are those which are attracted by the magnetic field. Those substances which are attracted by the magnetic field, they are called as paramagnetic substances. Those are repelled with each other, they are called as what? Diamagnetic substances. Therefore, what are the 2 major type of magnetic substances? The 2 major type of magnetic substances are paramagnetic substances as well as diamagnetic substances. What are paramagnetic substances? The substances which are attracted by magnetic field, they are called as paramagnetic substances. The substances which are repelled by magnetic field, they are called as diamagnetic substances. Question arises, why few substances attracted by magnetic field? Why few substances are not attracted by magnetic field? This will depend upon unpaired electron. If any substance or any element, if it contain unpaired electron, they are attracted by magnetic field. If they does not contain unpaired electron, all the electrons are got paired up. So then they are repelled by magnetic field. Therefore, any substance or any element behaves as paramagnetic when it contains unpaired electron. As the number of unpaired electron increases, the paramagnetism also increases. Therefore, paramagnetic nature is due to the presence of unpaired electron. Paramagnetic nature is due to the presence of unpaired electron. Therefore, in your competitive exam, how do you identify whether the substances are paramagnetic as well as diamagnetic? Write its electronic configuration. Observe whether they contain unpaired electron or not. If it contain unpaired electron, they are paramagnetic. If it does not contain unpaired electron, they are diamagnetic. As well as which is more paramagnetic, which contain more number of unpaired electron. For example, in the 3D series, when I consider scandium to zinc, the first element in 3D series is scandium with atomic number 21. Next, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. From scandium to manganese, number of unpaired electron increases. Therefore, from scandium to manganese, the paramagnetism increases. Therefore, paramagnetism is maximum at middle of the series, that is for manganese, the paramagnetism is more because it has 5 unpaired electron. Manganese has 5 unpaired electron. Therefore, paramagnetism of any substance or any element because of the presence of unpaired electron. Because of the presence of what? Unpaired electron. So, this paramagnetism is measured by magnetic moment mu. The paramagnetism is measured by magnetic moment mu. Magnetic moment mu is equal to square root of n into n plus 2. What is the formula to calculate magnetic moment? Magnetic moment mu is calculated by using formula mu is equal to square root of n into n plus 2. N into n plus 2, where n is equal to number of unpaired electron. Where n is equal to number of unpaired electron. What is the n? N notation, n represents number of unpaired electrons. Number of unpaired electron. Therefore, how do you calculate magnetic moment? Magnetic moment is calculated by formula mu is equal to square root of n into n plus 2, where n is equal to number of unpaired electrons. N is equal to number of unpaired electrons. Okay, so already I explained that thus the magnetic moment is increases with increase in the number of unpaired electron present. Hence, observed magnetic moment is useful to know the number of unpaired electron present in an atom. In the first transition series, as the atomic number increases from 21 to 25, 21 to 25 means scandium to manganese, the number of unpaired electron in 3D increases from 1 to 5. Hence, the magnetic moment or paramagnetic character increases, becomes maximum at manganese. However, thereafter the number of unpaired electron decreases with increase in atomic number. As such, paramagnetic character decreases. So, scandium to manganese, number of unpaired electron increases, that is from 1 to 5. Scandium has 1, vanadium, titanium has 2 unpaired electron, vanadium has 3 unpaired electron. As scandium to manganese, number of electron increases from 1 to 5. Therefore, its paramagnetism also increases. After manganese, as number of electron decreases, the paramagnetism also decreases. When you consider zinc, the last element with atomic number 30, it has 3d10 electronic configuration. 3d10 electronic configuration means all the 10 electrons are get paired up in 5 orb subshell. So they are colorless. They are diamagnetic because they does not contain any unpaired electron. Does not contain any unpaired electron. Now, from this, 2 mark very important problem for your board, as well as it's also very important question you have competitive. Calculate the magnetic moment of cobalt. Calculate the magnetic moment of cobalt in +2 oxidation state. Cobalt in +2 oxidation state. Already you know that cobalt, its atomic number is 27. Its atomic number is 27. Ar 4s2, Ar, argon is 18, 4s2 20. So 3d7. When I write box diagram for this, as you know, d orbitals are blocked into 5 suborbital, 4s only 1 subshell. Okay, 3d. So 3d7 means first each box is accommodated by 1 electron. Each box is accommodated by 1 electron. According to Hund's rule, the pairing of electron takes place by only each atomic orbital is accommodated by single electron. Therefore, first I will put 1 electron to each box, rest of the 2 electron. Therefore, how many unpaired electrons are there? N is equal to 3, 4s, 2 electron. N is equal to 3. Therefore, number of unpaired electron in cobalt in +2 oxidation state, that is how many unpaired electron? 3 unpaired electron. Therefore, number of unpaired electron N is equal to 3. Number of unpaired electrons N is equal to 3. Number of unpaired electron in cobalt in +2 oxidation state is 3. Therefore, mu is equal to square root of N into N plus 2. N is 3, 3 plus 2, 5, 3 5 is a root 15. Value of root 15 is 3.87. The unit of magnetic moment is Bohr magneton. Bohr magneton, or you write B dot M, Bohr magneton. What's the unit of magnetic moment? The unit of magnetic moment is Bohr magneton, B dot M. What's the value of mu for cobalt in +2 oxidation state? 3.87. This the magnetic moment value for cobalt in +2 oxidation state. Before calculation of magnetic moment, first you have to find out the number of unpaired electron, that is N. N is number of unpaired electron. Next problem. Calculate magnetic moment of iron in +2 oxidation state. So, Fe, iron. What is the atomic number? Z is equal to 26. If you write electronic configuration, argon 4s2, 3d6. Argon is 18, 4s2 rest of the 6. So, if I write in box diagram, Ar, 3d means how many box I have to write? 5. 4s, this is 4s, how many electron? 2 electron. 3d6, first I'll put each box 1 electron. According to Hund's rule, 3d6 means I have to put 1 electron into each box. Therefore, I filled 5 electron. There are 6 electron. One more I'll put here. Now, unpaired electron is equal to 4. N is equal to 4. Now, what's the formula for the magnetic moment? So, mu is equal to square root of N into N plus 2. Here N is equal to 4. 4 into 4 plus 2. 4 into 6, 24. Square root of 24 is 0.90. The unit is B dot M. What is B dot M? Bohr magneton. What is B dot M? Bohr magneton. What is the number of electrons? Unpaired electrons is equal to 4. What's the formula to find out magnetic moment? Mu is equal to square root of N into N plus 2. Square root of N into N plus 2 is the formula which is used to find out magnetic moment. Okay. Next, calculate magnetic moment of chromium in +3 oxidation state. As you know, chromium with atomic number Z is equal to 24. We have to write electronic configuration argon 4s1 3d5. 4s1 3d5. Okay, argon is 18, this one is 19 plus 5, 24. Therefore, electronic configuration in box diagram, so Ar 3d5, and this is what? 4s. 4s, how many electron? 1 electron. 3d is 5 electron. According to Hund's rule, each box should be accommodated by 1 electron. Alige N is equal to 5. How many number of unpaired electrons are there? N is equal to 5. The mu is equal to square root of N into N plus 2. 5 into 5 plus 2. 5 into 5 plus 2. 5 into 7. Square root of 35. So, when you consider square root of 35, it comes nearly 36 means square root of 36 means 6. It nearly come across 5.9. B dot M. What is B dot M? Bohr magneton, the unit of magnetic moment. So, in the not only these three problems, so they'll ask any ions magnetic moment. If you know the concept how to calculate magnetic moment, to calculate magnetic moment you are able to write electronic configuration. Therefore, if you know electronic configuration, from that you calculate number of unpaired electron, and as you substitute in the formula, mu is equal to square root of n into n plus 2. Mu is equal to square root of n into n plus 2. What is n? N is number of unpaired electron. What's the unit of magnetic moment? The unit of magnetic moment is Bohr magneton, B dot M. Now, trends in properties of transition metals of first series. Formation of colored compounds. I am talking about now color. The most of the compounds of D block elements they are colored. Was the color emitted, or what the color you are observing from your eyes? It is the complementary color to the color which is get absorbed. Color which get absorbed. Color which get absorbed. Color which get absorbed is complementary color to the color which get absorbed. This is absorbed. This is absorbed. So most of the D block elements compounds are colored in their solid state or in their solution state, because that compounds absorbs certain light of certain wavelength from the visible part. That is, what is the visible region? Visible region is 400 nanometer to actually 760 nanometer. 400 to 760 nanometer. X-rays, IR rays, radio waves, they are not visible to our eyes because their wavelength is not less than 400 and more than 760 nanometer. Therefore, the color which is emitted, color which is absorbed is a complementary color to the color which is absorbed. The actual color of the substance depends on the wavelength of the color which is absorbed from white light. The color of this transmitted or reflected light is the color of the substance. It is complementary of the color which is absorbed by the substance. Transition metal ions containing unpaired electron. Here also, those containing unpaired electrons or vacant d orbitals are colored. Naturally, transition metals which have completely filled d orbital, they are colorless, because there is no unpaired electron to get excited from lower energy level to higher energy. When they come back from higher to lower, they emit radiations or light which is the complementary color to the color which get absorbed. Therefore, the ions are completely filled d orbital are 3d0 and 3d10. They are color. For example, zinc salts. Zinc salts are colorless because they have 3d10 configuration. When you consider Cu plus ion and Cu2 plus ion, Cu plus means Ar4s0 3d10. Cu2 plus means Ar4s0 3d9. Here it is Cu plus has completely filled d orbital. Therefore, Cu plus R colorless, Cu2 plus are colored. Therefore, cuprous salts are colorless, cupric salts are colored. Why cuprous salts are colorless? Because they have 3d10 electronic configuration. It has completely filled 3d orbital. Why cupric ion is colored? Because they contain 3d9 configuration. They have 3d9 configuration means it has one unpaired electron. That's why those which are containing unpaired electron, they are colored in nature. Those who do not contain unpaired electron, they are colorless. Beautiful example for colorless salts are zinc salts are colorless because they have 3d10 configuration. Cuprous are colorless because they have 3d10 configuration. Cupric ion is blue in color because it has 3d9 configuration. See, scandium 3d0 colorless. Those have 0 number of unpaired electrons 0. They are colorless. Scandium in +3 oxidation state, titanium in +4 oxidation state, copper in +1 oxidation state, zinc in +2 oxidation state. These are colorless. On the board you are observing those have unpaired electrons 0. They are colorless. See, which ions are 0 unpaired electron? So scandium in +3 oxidation state, titanium in +4 oxidation state, copper in +1 oxidation state, zinc in +2 oxidation state. Observe, titanium in +3 oxidation state was the color. Vanadium +2, +3, +4, +5 had given colors. Vanadium in +2 purple, it is green. Okay, so here observe here, titanium in +1 oxidation state purple, vanadium in +3 green, chromium in +3 violet, manganese in +3 violet, manganese in +2 light pink, ferrous in +2 green, ferric yellow, cobalt 2 plus pink, nickel 2 plus green, Cu2 plus blue in color. All cupric salts are the blue in color. These are the colored. See, I had given here titanium in +3 oxidation state +4, vanadium purple, vanadium in +2 oxidation state purple, +3 green, +4 blue, +5 yellow. Chromium in +2 blue, chromium in +3 green, chromium in +6 it's orange. So manganese pink as well as violet. So here iron, so next to cobalt, next to nickel, next to copper. These are the color. I display some of the transition metals ion color on the screen. Observe, my dear student, the color I displayed for all titanium, vanadium, chromium, manganese, iron, cobalt, nickel as well as what? Copper. As well as what? Copper. Now, the sixth property of this 3D series as well as the first series are most of the metals which are belongs to 3D series, they behave as catalyst. Okay, what is catalyst? Catalyst is a substance which alters the velocity of a chemical reaction without undergoing any chemical change. It may undergo some physical change. Most of the elements and their compounds behave as catalyst. This catalytic behavior is considered, according to modern theory of catalyst, catalytic form an intermediate. For example, when I consider A and B in the presence of catalytics, they'll form intermediate. This is called as what? Intermediate. That is, reactant A and B form temporary bonds with catalyst X. Then it decomposes to give products. With the regeneration of catalyst X. Okay. According to modern theory of catalysis, the catalyst form an intermediate unstable compound with reactant. This intermediate compound readily decomposes to give the product and the catalyst is what? Regenerated. This is because of the variable oxidation state. Why most of the D block elements and their compounds behave as catalyst? Because of the variable oxidation state, and they'll form unstable intermediate compound readily. These elements also provide large surface area for the reactants to be absorbed side by side. This helps the reaction to occur on the surface of the catalyst. This the reaction which takes place, which occurs on the surface because of the variable oxidation state, and they provide large surface area to get catalyst must be adsorbed, not absorbed. Adsorb means catalyst molecules are get accumulate on the surface of the catalyst or not on the bulk of the catalyst. Few examples says, as you know, ammonia is manufactured by Haber's process. The manufacture of ammonia by Haber's process, we take iron as a catalyst, and hydrogenation of oils and unsaturated hydrocarbon. Which one act as catalyst? Nickel act as catalyst. And vanadium pentoxide V2O5, which act as catalyst in the manufacture of sulfuric acid by contact process. Ammonia by Haber's process, sulfuric acid by contact process. When you want to manufacture ammonia by Haber's process, which one act as catalyst? Iron act as catalyst. In the manufacture of sulfuric acid by contact process, vanadium pentoxide act as what? Catalyst. So iron is act as catalyst for Haber's process, vanadium pentoxide act as catalyst for contact process, nickel act as catalyst for hydrogenation. Next, the seventh property of 3D series or first series, formation of interstitial compound. When I consider solids are arranged in certain crystal lattice. When I consider here the hard spheres of the solids, they are arranged like this. So when these spheres are kept one above the other, so the space which is covered by these spheres, it is called as lattice side. It is called as what? Lattice side. And the space which is not covered, they are called as voids or interstitial sides void or interstitial side. These are called as lattice side. And this is called as what? Hole or what? Interstitial side. In this interstitial site is filled by or trapped by small atoms like carbon, nitrogen, hydrogen and boron. Then there is a formation of interstitial compound. So small atoms like hydrogen, carbon, boron and nitrogen, they filled in interstitial sites or voids of this crystal lattice. The interstitial compounds are those which are formed when small atoms like hydrogen, carbon, nitrogen are trapped inside the crystal lattices of transition metals. Okay, they are non-stoichiometric. They are not stoichiometric compound. They are non-stoichiometric, neither typically ionic nor covalent. These interstitial compounds have similar chemical property as that of the parent metal. Parent metal, whatever it has similar chemical property, same chemical properties are shown by interstitial compound, but they differ with respect to the physical property like density, melting point and hardness. Interstitial compounds are hard and denser. This is because the smaller atoms of the lighter element occupy the interstices of lattice, leading to more closely packed structure. Due to greater electronic interaction, the strength of metallic bond also increases. They retain metallic conductivity. For example, TiC, Mn4n, Fe3H, vanadium hydride 0.56, titanium hydride 1.7. These all are example for what? Interstitial compounds. Interstitial compound. Last point, alloy formation. Last point, alloy formation. Transition metal form a large number of alloys. Large number of alloy. Alloy is formed by the metals whose atomic radii almost all similar. 3D series elements are quite similar in atomic size and other characteristics. Hence, the atoms of one metal can substitute the atoms of other metal in crystal lattice. On cooling the molten mixture of more than 2 transition metal, solid alloys are formed. So, most of the 3D series, they'll form alloy with itself. For example, chromium, vanadium, manganese, nickel are used with iron to form variety of steels. So, as you know, in steels there are different types: stainless steel, tool steel, maraging steel, like that. So many types of commercial varieties of steel. These steel is when iron is alloyed with chromium, vanadium, manganese, nickel. So they'll get we'll get a variety of steel. Alloys like brass, brass is copper is mixed with zinc. Bronze is copper is mixed with tin. Copper and zinc. Copper and zinc is called as what? Brass. Bronze, copper and what? Tin. So today in this class I discussed about the 5 properties of 3D series. Like first one, magnetic property. Second one, why they are colored in nature. Third one, catalytic behavior. Fourth one, how they form interstitial compound. Last one, alloy formation. So these 5 points I discussed in this session, that is of first series as well as what? 3D series. Next session I am going to deal with one compound, that is potassium dichromate. Potassium dichromate is a very good oxidizing agent and it's a compound of chromium with formula K2Cr2O7. In the salt analysis also in the laboratory, it is used in both qualitative analysis and quantitative analysis. Next session, that is in the 4th session, I am going to deal with one compound that is called as what? Potassium dichromate. Therefore, in the next session, that is in the 4th session, I'll come up with new concept that is like potassium dichromate. Until that, goodbye. Thank you, my dear students.